Hi and welcome to His Grace Academy online mathematics class. And if you have not watched the previous episodes on this topic, circle geometry, please go and do the needful so that you will not be missing any bit of our discussion on this topic. So for the immediate class, we want to begin the application of those theorems we have previously considered. So those theorems, we want to begin to do the application where necessary. Now look at this question. This is NECO 2006, question number 39. NECO 2006, question number 39. In the diagram below, O is the center of the circle XYZ. If angle SOZ is equal to 301 degrees, find angle XYZ. The question again, in the diagram below, O is the center. You can see this is the O, the center of the circle XYZ. So XYZ, they are points on the circle, and the center of that circle XYZ is O. Okay, so if angle SOZ is 301 degrees, that is angle XOZ, the angle at the center. You see, the angle at the center has two cases. We have the obtuse case and the reflex case. So like this case now is the reflex. Of course, you know what a reflex angle is. It's an angle that is greater than 180 degrees but less than 360 degrees. So this is the reflex. This other side is the obtuse case. So these two, they are conjugates. They add up to 360 degrees. So this is the reflex case and this is the obtuse case. So the angle at the center has two cases. We have the obtuse case and the reflex case. But in this regard, this 301 degrees of the angle at the center is the reflex case. This is the reflex case. So angle SOZ is 301 degrees. Then we have to find angle SYZ, and that is the angle here. SYZ, the angle here. And that angle is the angle at the circumference. The angle at the circumference. So remember one of those theorems that states that, you see, you know, this is an arc. This is an arc. And yes, now, the arc that sustains this angle at the center, the arc that sustains this angle at the center is equally the arc that sustains this angle that we have to find at the circumference. So this and these angles, they are in the same arc. So, and remember that theorem which states that the angle which an arc of the circle sustains at the center is twice that which is sustains at the circumference. So the angle at the center doubles the angle at the circumference. So if we are able to know this center, we can easily get the circumference, because half of the center is that the circumference. So we are given this angle, we are given this side as 301 degrees. So we can easily find the other side. Okay, so let's do that quickly. Quickly. So that's angle SOZ, angle SOZ. I told you there are two cases for center, reflex and obtuse. So the SOZ that I'm talking about in the first case is this side, and that is the obtuse plus angle SOZ, this side now, and that is the reflex, plus angle SOZ, and that is the reflex, is equal to 360 degrees. And that is a summation of angles at a point. Or you just say conjugate angles. Conjugate angles. Conjugate angles are two angles that add up to 360 degrees. So let's substitute now. SOZ and that is the obtuse. So it is not given. We don't know the value yet. So that's angle SOZ. The obtuse is unknown yet. Obtuse. Okay. Plus angle SOZ. SOZ. That's the reflex. We are given the reflex, and that is the 301. So plus 301 degrees. We add up to 360 degrees. That's conjugate angles. Total angles at a point. So these are like times. Is that not? So the needful is, we need to collect the like times. Okay? Collect like times. So the collection now will result to having angle SOZ, which is that obtuse, okay? Which is the obtuse. I guess that is equal to 360 degrees. You see, plus this to this side, that is minus 301 degrees. So if you take that difference now, that is 360 degrees minus 301 degrees, that will equate to 59 degrees. Okay, so this angle now is 59 degrees. This angle is 59 degrees. I guess now. So that's is now acute. We have the acute and the reflex. So this angle now is acute now. You see the angle there is acute angle bar. It is less than 90, so it is acute. So you can change this to acute. So let's move on. To now get the angle here, having got this center, we can get this circumference. So angle SYZ now. Angle XYZ, which is the circumference, is equal to half of angle SOZ. Half of angle SOZ. And the SOZ there is this case. So that's 1/2. The reason is angle at the center doubles the angle at the circumference. Angle at the center doubles the angle at the circumference. So half of SOZ with this case now, that's this side. Half of this side is this side. Times 2 of this side is this side. So that is half of, what is that? 59 degrees. And half of 59 is, that's 29.5 degrees. And that is very trivial. Very trivial. So the option that satisfies that justification is option E, and that is very correct. So thank you, and get ready for more application of the theorems in our subsequent episodes. Bye. Please remember to subscribe to this channel. God bless you.